All right, so this was one of the problems from our formative quiz today. It didn't go extremely well, but I did not do this one in class because we had done one of the other ones, and this is kind of a review problem. So I'm going to go ahead and work through this really quick. It said there's a radio transmission tower that's 100 feet tall. That seems to be important. It says how long should a guy wire, I don't even know what that is, be if it was attached 7 feet from the top of the tower, so 7 feet from the top, and is to make an angle of 23 degrees with the ground. I guess with the ground becomes pretty important too. Give your answer to the nearest foot. So let's just start. I know there's this tower, and I know it's 100 feet tall. Okay, so I've got that. And there's a guy wire, and it says it's attached 7 feet from the top. So 7 feet from the top. Well, I can't go up if this is actually the top right here, so I have to go down. So that's 7 feet. Interesting. And so there's a wire that's attached there? And it says the wire is attached 7 feet from the top, and it makes an angle of 23 degrees with the ground. So this wire has to go from there somehow to the ground, and it makes an angle of 23 degrees. Now I really do kind of know. I've never heard the term guy wire prior to this, but if you think about it, if you've ever seen kind of wires, or sorry, like a canvas tent where you have strings that are holding them up, or any kind of tent and you have strings that are, you know, kind of supporting or pulling something out, or you know, if you've ever seen like a tower and you've got wires, like telephone poles, and you've got those wires that are coming off of it. That's really kind of what it's talking about here. So I know that this is 23 degrees. And it says how long, so this is really the important thing, how long should the wire be? That's really what I'm looking for here. So what I'm looking for is the length of this wire. I don't know how long that is, so I'm going to put that as L. So when I look at this, it seems like it's making a triangle to me. And if that's not the Leaning Tower of Pisa, I know that's a 90-degree angle, so I'm going to go ahead and work based on that. And if that top piece is 7 and the whole tower is 100, I really know that this is 93 feet right here. And so when I look from the angle that I have, I'm really looking at the opposite side to the hypotenuse. So that, because I know I'm going to use trig, so I'm really looking at opposite and hypotenuse. That means that I'm thinking this is going to be sine. So I get, ooh, wrong color. The sine 23 equals 93 over L. Now if I'm just going to solve this conventionally, I could go ahead and I realize I've got to isolate L, but L is in the denominator, so I'm going to go ahead and multiply both sides by L. And that's going to leave me with L times the sine of 23 degrees equals 93. And then I'd like to isolate L, so I need to get rid of this multiply by sine of 23. So I'm going to divide by the sine of 23. And if I do that to both sides, I would end up getting L equals 93 divided by the sine of 23 degrees. I want to make sure my calculator is in degree mode when I type that in. And I'm just going to type that into my calculator, and I would end up getting an answer of C. Ooh, that's a little bright. We'll go with a red circle. So hopefully that helps. Take a look at, if you really look at this, the problem with story problems for a lot of people is that we don't spend enough time making sense of the problem itself. Like, what is each thing? Think about what each thing is. Can I make a visual? What does this mean? What is it telling me? The more time you actually spend analyzing the problem and analyzing what's there and really thinking about it critically, the quicker the calculation portion, you know, that later portion is going to be. So spend that time reading and kind of thinking about those things, and you'll be all right. Hope this helps. Have a good night. Bye.